Hello. In this chapter we're going to look at the idea of counting. We're going to look at that in several different ways throughout the chapter. We're going to look at it in this first section just in ways of doing diagrams and lists and see if we can do some counting that way. Those ways are pretty limited, and we'll have to go to some easier ways of dealing with larger type counting numbers. And we'll do that in later chapters. But let's go ahead and get started with the notes from this section. Okay, so here is the notes, and we're going to start off with just an introduction into some counting methods. We're going to look at two basic types of counting methods. We're going to look at creating organized lists, and we're going to also look at creating tree diagrams. So in order to do this, I'm going to look at the following example. If you roll 2 dice, how many different pairs of numbers can appear on the upturned faces? And I'm going to look at that with the list first. So for the list, in order to determine what the differences are, I'm going to say that those 2 dice are different. I'm going to say that, that 1 die is white and 1 is red. And then what I'm going to do is I'm going to list them with the white die first and the red die second. And I'm going to try and do this in a real organized fashion. Alrighty? So I'm going to start with the white, and I'm going to say the first number the white could get is a 1. And then I'm going to go through all the different possibilities for red. So white could be 1 and red could be 1. Alright, so these are 6-sided dice. Alright. And the white one could be 1 again, or the red one could be 2. Or I could have a 1 and a 3, or a 1 and a 4, or a 1 and a 5, or a 1 and a 6. Those are my different options if I leave the white to be a 1. Or the white could be a 2. And if the white's a 2, then the red could be a 1. It could be a 2. It could be a 3. It could be a 4. It could be a 5, or it could be a 6. Or the white could be a 3, and then the red could be 1, 2, 3, 4, 5, or 6. Or it could be a 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Anyways, you get the idea as to what that's going to look like. And what you could do is you could say, let's go ahead and simplify what we have here instead of writing all of these out. Let's go ahead and figure out how many there would be. Well, there are 6 in this column for when the white is 1, and there would be 6 total columns because you could have a white being 1, 2, 3, 4, 5, or 6. And so we would have 6 columns, each of which had 6 possibilities in it, or you have 36 ways that those 2 dice could get rolled. All right, so that's one way to look at it, just by creating an organized list. Now notice if we had done rolling 3 dice, and let's say they were 20-sided dice, this would get pretty unreasonable in a real hurry. So we're going to need to look at some other ways of doing those later on. But let's look at creating a tree diagram. And a tree diagram, what we're going to do is we're going to say, all right, let's take a look at the different possibilities for white. It could be 1, 2, 3, 4, 5, 6. And then let's look at what's happening with the red. So if the white is 1, the red has 6 different possibilities. It could be 1, 2, 3, 4, 5, and 6. If the white is 2, we've got 6 possibilities again. 1, 2, 3, 4, 5, and 6. If it's a 3, we've got these possibilities, and it's going to keep going like that. So again, we're going to have 6 times 6 because we've got 6 different possibilities for the white. Each of those has 6 branches, so we've got 36 ways. And what I've done is I've created a sheet that may be helpful to you. If you go into your Blackboard And if you go to the chapter folders and open up the chapters 13 and 14 folder, one of the options here under the notes is the sample spaces. And if you open up that sample space, what it'll do is it'll give you some of the different things that could happen. Notice the first thing I have in here is rolling 2 dice. And what I've done is I've just listed all the different possibilities. And that can be helpful as you're working on some of the homework things. I've also got what the different sums are that you could get. Alrighty. And I've got what can happen if you've got, tossing some coins. Here's the different options that could happen, tossing coins, 3 coins and 4 coins. And I've got some what can happen with playing cards. All right, the different red cards, the different black cards, the different suits that you have, and the different kinds of cards that you have. These right down here are considered the face cards. Alrighty, so you'll have some questions that talk about those, and some people find that real helpful to have that. All right, but let's go back to our notes here, and now that we've got those, I want to look at some specific examples and see if we can set up either an organized list or a tree diagram to deal with those examples. Okay, so on the first one it says we've got a set S that contains A, B, C, D, and E. And we want to find a way to list all the ways that you can select 2 different members from S, and the order in which you select those members is not important. So in other words, you could start with, we're selecting 2 members, okay, and we can start by selecting A. And if you select A, then it's selected with B. A could get selected with C, A could get selected with D, or A could get selected with E. Okay, those are our different possibilities for A. Then we move on to B, and we could select B with A, but notice we've already got B with A, and we said that the order was not important. So if I write B comma A, that's the same as A comma B, so I wouldn't write it. But, and I'm using different members, so I wouldn't do BB, just like I wouldn't do AA. But I could do B with C, B with D, and B with E. And then I could go on to C, and I could say I've already got C with B, and I've already got C with A. So C can still be with D, and it can still be with E. And then I go on to D, and D's already been with C, it's already been with B, it's already been with A, so it could go with E still. And now notice I've got E with everything else, with D, with C, with B, and with A. And now I can just add up how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 ways that you could select 2 different members from that set. And all I did was I created an organized list to do that. All right. Now, if we had said that order was important, if order was important, then what would that do? Well, that would say, all right, I'm still going to have these 4, but now I'm going to have BA is going to be an option, so I'm going to have 4 options here, and then I would have CB would be an option, CA would be an option, so I'd have 4 here, so I'd have 4, 4, 4, and 4, or 20 different ways. So the verbiage that you're looking at is going to make a difference, whether the order is important, whether you're talking about different members or similar members. All those things are going to be important as you go through the problem. Let's look at the second one. How many different 2-digit numbers can you form using the digits 1, 2, 5, 7, 8, and 9, with repetition being allowed? For example, up here we didn't allow repetition because we said they were different. But down here you can put a 1 and a 1 together, a 2 and a 2, etc., etc. So if we do that, we could have 1 going with 1, all right? Or we could have 1 going with 2, or we could have 1 going with 5, or we could have one going with 7, or we could have one going with 8, or we could have one going with 9. So we've got 1, 2, 3, 4, 5, 6 different ways that that can happen. Then I could go to the 2, and I could say 2 goes with 1, 2 goes with 2, 2 goes with 5, 2 goes with 7, 2 goes with 8, and 2 goes with 9. Again, I've got 6 possibilities. I could have then go to 5, and 5 could go with 1, 5 could go with 2, 5 could go with 5, 5 could go with 7, 5 could go with 8, or 5 could go with 9. And I'm getting tired of this, and I see the pattern. I've got 6 in each row, and I'm going to have 1, 2, 3, 4, 5, 6 rows that are starting with the different numbers. So I'd have 6 times 6, or 36 possibilities. All righty? Now if we go to the last one, it says you're offering guests at your party options for a 3-course meal. You have 3 different appetizers, 4 main courses, and 2 desserts. How many different options can guests choose for their 3 courses? And I'm going to use a tree on this one. So let's start by doing an appetizer, and let's say we've got appetizer 1, appetizer 2, and appetizer 3. Those are our different appetizer choices. Then we've got 4 main courses. So if we choose this appetizer, we've got 4 mains that would come off of that. Main 1, main 2, main 3, main 4. 4 mains that would come off of this one. And then we've got our appetizer 3, and we have 4 main courses coming off of that one. All right. Then once we've picked an appetizer and a main, then we've got 2 desserts. So each of those is going to have 2 desserts, dessert 1, dessert 2, dessert 1, dessert 2, dessert 1, dessert 2. Okay? And then we're going to look at how many different possibilities. Well, we've got 1 possibility here when we go through that tree. We've got a second possibility here, A1, M1, B2. So there's 1, 2, 3, 4, 5, 6, 7, and 8. Or you can count up how many different branches you have down here. And there's 8 here. And notice that would be the same as it would be over here. You'd have 8 here, and you'd have 8 here. So you get a total of 8, 16, 24 different options. So that's the first way we can do counting, is just by doing either organized lists or setting up tree diagrams. And that's how we're going to get started on this idea of counting.